Alrighty, today we gotta talk about density. Your mass over your volume. It is your density. And so when we talk about what is density, the technical definition, if you look it up in a textbook or online, is it's a measure of mass per volume. So how much stuff is in a given amount of space. So our formula, if we say per is to divide, is mass divided by volume. So again, how much matter is in a given volume. So if we look at these with that definition, which box is more dense, or which box is denser? Which box has more matter in it? B. You see it has way more dots, which is our atoms, and so this one is considered the denser object. So let's say we have two boxes. They have the same length, same height, same width. So the same volume. They take up the same amount of space. But one is lead and one is styrofoam. So which one has more mass? The lead or the styrofoam? The lead, because it's way heavier than the styrofoam. So if we keep that in mind, which one of these blocks represents the lead and which one represents the styrofoam? So the denser block would represent the lead because it has more mass than the styrofoam does. So we gotta do a little bit of math. It's not that bad. So if you don't want to remember density is equal to mass over volume, we have this triangle over here. And the important part about the triangle is that you keep the M on the top. Mass goes on top. And the way I remember that is I always put M for me at the top because I'm always on top. So we have an object that has a mass of 4 grams and a volume of 2 milliliters. And we want to know what the density is. So if I cover up this D right here for density, we get mass over volume. So you cover up the one that you're looking for. So if we put 2 grams over 2 milliliters, we get 4 divided by 2 grams per milliliter is the density of this object. So now we have some gold because we're feeling bougie. The density of the gold is 20 kilograms per liter. And we have 4 liters of gold because we roll it. And we want to know what mass this is because we usually measure gold in grams, not in liters. So we're going to cover up that M right there at the top. And we have D next to V. So whenever two things are next to each other, what do? We multiply. So we're going to take that density of 20 grams per liter, multiply it by the 4 liters. The liters cancel, and we get 20 times 40 as 80 kilograms, which is a fair amount of gold to have. Last one on this. So our density of water is 1 gram per milliliter, and we have 50 grams of water. And we want to know what volume we have, because volume is usually measured in liters or milliliters. So we cover up that V over here, because that's what we're looking for. And we have mass divided by density. So I put the 50 mass divided by my density, the 1 grams per milliliters. Grams cancel, and we get 50 milliliters of water. And that's the end of the math for this. That's all the density math that you got to know. That density equals mass over volume, or you can remember the triangle. So let's think about this one. Why do some things float and some things sink? So if the density of your object is less than the density of the water, so the water has more particles in it, more atoms, then whatever you're sticking in it, like the styrofoam, it's going to float. Because that less dense object doesn't have enough matter to sink to the bottom, so it floats. If we have something with a lot of matter in it, like the lead, it's going to sink straight to the bottom because it has so many atoms in it that it just pushes all the water ones out of the way. All these atoms are so compacted together that the water ones just push out of the way so it can sink to the bottom. So let's continue this talk on water. So water is kind of our standard to measure density. For number one, it's everywhere. And its density is only 1 gram per milliliter or kilogram per liter, and so that makes math easy. But it's kind of only somewhat true because the density of water depends on the temperature. It also kind of depends on what's mixed in the water. So if you have a lot of salt in the water, that's going to affect their density, but that's not what we're talking about today. So let's think about this one. If you have water in the liquid phase and you heat it up to the gas phase, what happens to those molecules? Are they more compacted or are they more spread out? And what does that mean in terms of density? So if the water's in a liquid phase, those molecules are more compacted than if they're in the gas phase. So when they're in the liquid phase, you could think that they're more dense in a way. It's a more dense state of matter because these molecules are packed together versus when they're in a gas, they're more spread out like an object that's less dense. So now that we're thinking about that, if we have hot air and we have cold air, which one do you think is denser? Have you ever heard the phrase heat rises? Well, it's true. The hot air, like we were talking about, those molecules are moving apart faster because they're in the gas phase and you're heating them up. And so that makes hot air not as dense as cold air because those cold air molecules are not moving as fast, so they're closer together. So if I had some hot air and I had some cold air and I put them together, what do you think is going to happen? Which one's going to sink and which one's going to float? Well, the hot air is going to go up to the top and the cold air is going to go to the bottom. And that's just how the density of the air works because the hot air is moving so much faster that it pushes all that cold air to the bottom. So now let's think about this one. How do hurricanes form? So we've got this hot air near the surface of the earth. Because remember, we have a hot core and all this magma out around our core that makes the planet hot. So we have all this hot air near the surface. And if you think about it, as you go higher up, the atmosphere gets colder. So we have cold air higher up because you're further away from our warm planet. But what we just said is that the hot air wants to be on top because it's not as dense. And so by properties of density, the hot air wants to be on top, but it's not. And so what ends up happening is that this hot air shoves all the cold air out of the way when you have the two coming together, and you create this kind of funnel almost where the hot air is rising and it's pushing all this cold air down, and you eventually create this turbine that is a hurricane. And since the hot air that creates hurricanes is usually really humid air in really humid areas, you make all these clouds that have all this rain in them because it's so humid and it's getting spun around by this distribution of hot air and cold air that you get this vicious hurricane storm. And that's how density creates hurricanes. And so go ahead and come back to class, and now we can talk about why metal ships float.